the cross, so crossing in cytosol. So, in other words, this is a carboxylic acid group. This molecule has created free fatty acids, right? Pancreatic lipase or something else has popped a fatty acid off, and there it sits. So, it's going to go through into my cell. It's going to cross the brush border membrane, right? It's going to go through that water layer. As soon as this gets into the cytosol, like so in here, we're in the enterocyte.
And the water layer was
Yeah, that's. I guess I was getting confused as to what was happening in the water layer and what was happening.
So the water layer encourages even more so than the lumen the formation of my cells, because once you get to that water layer, you're interacting with that polar water, and so they're going to continue to form into my cells. And as they form into my cells, we go back over here. It's kind of a self-reinforcing process, because you've got these hydrophilic groups over here that are interacting with the water, and then they're just going to keep moving through. In other words, so once you've got a micelle, if it's at the water, it's going to go, oh, water, I can interact with water, and keep moving. So it keeps moving and keeps moving. And at the same time, the gradient, the difference in the fatty acid concentration of the enterocyte versus the water layer and also the lumen drives the intake. Because we change these things back from fatty acids to these esterified bonds, that also drives the micelles to come through. That's the gradient.
But where was the water layer located?
Water layer is right up here. Okay, so here's water layer.
So is it before the brush border?
Yes, so let's draw it. Okay. So here's our water layer. Oh, that's going to look the same. We'll call it water. And here's our little micelle. So, it's got those two polar groups, or if it's a phospho, right? If it's got a phosphate group on the end, we've got our OH, and then our fatty acid hanging down that way, and then our polar group, okay? So, it's going to go through the water. The more those polar heads interact with the water, the more those polar heads want to interact with the water. Which means instead of hanging out at the surface, it's going to get drawn into the water layer. As it gets drawn into the water layer, what happens is there's a high fatty acid concentration. Out here, there's a low fatty acid concentration in here. So these things want to move. They want to come in based on the gradient. This gradient is maintained because the COO minus gets transformed into a C double bond O linkage. These two shapes, because these have C's on both sides, they're not the same. They don't interact the same, and it's not perceived as the same molecule anymore. You've changed it from a carboxylic end group to an ester middle group. Because you've changed that, you keep this gradient going. So once these micelles interact with the water, they interact more. Once they interact more and get closer and closer to the brush border membrane, they want to cross because there's a gradient difference. They're just diffusing. We're just moving across from an area of high concentration to an area of low concentration.
Where does the reacidification happen?
That's in here. As soon as it gets inside the cell. Yeah, sorry. Okay, let me stop and take some pictures because that'll give everybody's brain a second to process.